Hi guys, welcome back to the channel. Jag here. And in today's class, we're going to continue with our Math 10 content on analytic geometry. So with that, let's get started. All right, so here we are. And I'm going to basically read out the question and we're going to try it on here. All right. So on a city map, the coordinates of two department stores are given. So let's put D1, like department store 1. The coordinates are 4 and 3. Okay, and department store 2, we'll put D2. The coordinates are given as 1 and 7. Okay. So it's saying how far apart are the stores if each unit on the map represents 1 kilometer. Okay, we're going to put it into the formula for length. I'm going to write the formula out. Okay, make sure you are memorizing, okay, all of these formulas. So it's x2 minus x1 whole squared plus y2 minus y1 whole squared. Okay, if you get confused, I always label my 2 points. That's x1, y1 and x2, y2. Okay, I'm going to plug it into my formula here. And you have to be careful to just watch the signs, okay? So we're going to do x2, so 1 minus x1, which is 4. So 1 minus 4 whole squared, okay? Plus the y2, which is 7, minus y1, which is 3. Okay, I'm going to subtract the two numbers here. Okay, and I'm going to write out my steps here. So 1 minus 4, which is negative 3. And 7 minus 3 is 4. Okay, so we're doing 4 squared. Okay, we're going to take the square root here. So remember, this is negative 3 whole squared. So negative 3 times negative 3, positive 9. Plus 4 squared, which is 16. Okay, you're going to add it together, which is 25. When I take the square root of that, it's equal to 5. Okay, so again, how far apart are the stores if each unit on the map represents 1 kilometer? So this is going to be 5 kilometers. Okay, so let's put therefore statement. So therefore, I'm going to put the stores are, okay, 5 kilometers apart. Okay, does everyone see that? Okay, and all we did here was basically take our two coordinates and we plugged it into the formula for the length. And that basically gives me my answer. Okay, and in this case, it's a specific example in terms of an application question. Okay, and the stores are 5 kilometers apart. Okay, are there any questions here? Okay, so good, that looks good. So let's go to the next question, okay, that we're going to try. So I'm going to put just example here. And what we're going to do in this question, okay, is we're going to try and classify this triangle, okay? So the vertices of triangle A, B, and C are given. So I'm going to just write out the, okay, three vertices, okay, and then C, okay, is equal to 10 and negative 1, okay? So these are my 3 points, okay, and I'm just gonna double check it. That looks good. Okay, and it says determine the length of each side of the triangle. Okay, now, so because it's a triangle, okay, I know that it only has 3 vertices. I don't actually have to graph this out. You can if you want it to be a little bit visual and you like seeing the triangle itself, I would graph that out as well. Okay, so we're going to start off with side AB. Okay, so once again, I'm just going to put the formula here. Y1 whole squared, okay? And we're doing basically A and B here, okay? So I will still label it, okay? After you get really good at it, you don't need to label it. Okay, but I'll have to cross it out when we're doing the other sides. Okay, so x2, so square root. And again, make sure you are putting the square root sign, okay, throughout your answer. Okay, so we're going to do negative 6 minus 2 squared. Okay, and check the points here. y2 is negative 1 minus 5. Okay, and then we're going to square it. Does everyone see that? Okay. And it's really important we are watching the sign. So negative 8 squared plus negative 6 squared. So negative 8 squared, 64. And negative 6 squared is 36. All right. You're going to add that together, which is 100. Square root of 100 is equal to 10. Okay. So that's side AB. Okay. And I think we have enough room here. So let's try BC. Okay. And so one more time, I'm just going to take this out. And this time we're doing BC, okay? And this will become x2, y2. Okay, and I always change around the points so I don't get confused here. Okay, so x2, so 10 minus negative 6. Okay. And then we're going to do y2, which is negative 1 minus negative 1. And then squared, okay? So I'll leave some room here. Make sure you are adding, okay, both of these together. So this is 10 plus 6, so 16 squared. And this is negative 1 plus 1, which is 0. Okay, or like 0 squared, which is still 0, so it doesn't really matter. Okay. When you actually square this is, I'm just going to show it to you anyways. So 256 plus 0. And then it's basically like I'm taking the square root of this again, and it's still equal to 16. Okay, so this is side BC. All right. And lastly, let's do side AC and the length. Okay. Oh, so we could have just left this here actually, x1, y1. Okay. So we're going to look at A and C. Okay, so make sure you are looking at, okay, the formula. Okay, and what it is that you are subtracting. All right. So right here, we're going to do negative 1 minus, oh, so let's start with the x2 actually. Okay, so 10 minus 2, and then squared. And now you could do the y values as well. So negative 1 minus 5. Okay, and then we're going to square them. Okay, does everyone see that? So we're going to do square root. Okay, so 8 squared. And this is negative 6 squared. Okay. So just like this, okay, is equal to 64 plus 36. I'm going to add that together, which is 100. Okay, then I'm taking the square root of the 100, which is equal to 10. Okay, so that's all we're doing for part A. Part A said to determine the length of each side of this triangle. And that's what we did basically, okay? These are all of the different combinations that we can have for all three sides, all right? And determine the perimeter of the triangle, okay? So let's write it here. I'm going to put perimeter equals. All I'm doing is basically adding up all my points and the final lengths that I got. So you're doing 10 plus 10 plus 16. Okay, so just like this, which is equal to 36. And I'm going to put units here, okay? Because in this question, this is analytic geometry. If they don't give you an exact unit, you should just put units. Okay, because it's kind of like you're just graphing it on the graph paper. Okay, so this is the perimeter of the triangle. And secondly, we're going to classify what kind of triangle this is. Okay, and I noticed that basically I have two sides that are equal. Okay, and the third side was 16, which is different. So I'm going to put therefore. Okay, let's put this is an isosceles triangle. Okay, and I always put down the reason for that. Okay, so let's put because two sides are equal. Okay, so I can see basically in this example, I can actually use analytic geometry to classify my triangle as well. I'm just putting it into the formula for length. Okay, and that's basically giving me the length of all three sides. And then you can just compare them as well. So if two sides of the triangle are the same, this is an isosceles triangle, just like this example. If all three sides were different, okay, that would make it a scalene triangle. And if all of these sides ended up being 10, it would be an equilateral triangle. Okay? And that's how you're using analytic geometry. Okay, I can find the perimeter of a triangle or any other shape as well. It could be like a rectangle or a square, because I just need to put all of my values into the formula for length. All right. All right, so that looks good. Thank you for watching this video. Please make sure you do like, share, and subscribe to the channel. And I will see everyone next time. Thanks. Bye.